We have three periodic trends: atomic radius, ionization energy, and electronegativity. We're going to start with atomic radius. We can define it as the one-half distance between the nuclei of two atoms of the same element. The atomic radius increases right to left across a period, because electrons are added left to right across a period to the same valence shell. Simultaneously, positive protons are added to the nucleus. The effect of the positive protons is greater than the negative electrons, so there's a higher effective nuclear charge. The nucleus attracts the electrons more strongly, decreasing the atomic radius. And the atomic radius increases down a group. Valence electrons are added to shells further away from the nucleus as shells are added. The outer electrons are shielded from nuclear attraction from the inner electrons via electron shielding. Then we have the ionization energy, that this is the amount of energy needed to pull an electron away from the atom in the gaseous state, or the tendency of an atom to give up electrons. A factor that affects ionization energy is electron shielding. This is the shielding of the valence electrons from the nucleus by the inner electrons. The ionization energy increases from left to right across a period. This is due to increasing effective nuclear charge, and decreases from top to bottom down a group because of electron shielding. And the noble gases have very high first ionization energy, so they have full valence shells. And finally, we have electronegativity. Electronegativity is a measure of attraction an atom has for bonding electrons, or how badly the atom wants another electron. The higher the electronegativity, the more desperate for an electron the atom is. Electronegativity increases from left to right across a period. The closer the valence shell is to full, the stronger the pull of that atom on the electron is a bonding pair. Electronegativity decreases down a group. The further the valence electron shell is from the nucleus of an atom, the weaker the pull of the atom on the electrons in a bonding pair. For the second topic, we have chemical bonds. There are three chemical bonds: the ionic one, covalent, and metallic. The ionic one is only between a metal and a non-metal. In the ionic bond, the attraction between positively charged metal ions and negatively charged ion occurs. Each atom acquires the electron configuration of a noble gas to obtain stability. Metals lose one or more valence electrons in order to attain a noble gas configuration, form cations. Nonmetals easily gain electrons to attain a stable outer electron configuration. The covalent bonds are bonds created by the sharing of valence electrons by two non-metal atoms. The real molecules are formed. The pair of points is replaced by a horizontal line to represent the pair of electrons shared. The covalent bonds can be single, double, or triple. And the covalent bonds can be polar, that is, between different atoms, the shared electrons are attracted more to one atom to another, and non-polar, that is, between equal atoms, electrons are shared equally. Finally, we have the metallic bonds, that are the attraction of a metallic cation for the delocalized electrons. Within the crowded lattice, the outer energy levels of the metal atoms overlap. Then we have the electron C model, that says that all the metal atoms in a metallic solid contribute their valence electrons to form a sea of electrons that surrounds the metal cations in the lattice. And for the last topic, we have the intermolecular forces, that are the interactions among molecules. We have three of them. First, the ion dipole, then the hydrogen bonds, and then the van der Waals forces. We're going to start with the ion dipole, that are the interaction between an ion and a polar molecule. Then we have the hydrogen bond, that is the interaction between a partially positive hydrogen and a highly electronegative element. And finally, we have the van der Waals forces. There are three. First, we have the dipole-dipole, that are the interaction between two polar molecules. Then we have the dipole-induced dipole, that are the polar molecules and nonpolar molecules that, due to the proximity of an electronegative element, is attracted to the polar molecule. And then we have the London dispersion, that are between non-polar molecules due to the movement of electron clouds.